Now today we will see some questions which are important and expected questions. Hope this type of questions will come this year. In which of the following reactions product will be aldehyde? The four options given is an alkene, a substituted alkene, and ozonolysis followed by the reductive, that is process in the method. So you will get 2 moles of acetone. So this is the wrong answer. The B is a propene reaction with the carbon monoxide and hydrogen in presence of a cobalt tetracarbonyl. This process is called oxo process and it gives an aldehyde. So the CHO group is added on the first carbon as well as the second carbon. Major product will be the isotype of answer. Follows Markovnikov rule but still gives a CHO group on the second carbon. So the third answer is propene, and following the that is called Waker's process, palladium chloride oxidation follows Markovnikov rule. You will get a 2-propanol. 2-propanol will be the answer. And the D will be the alkyne. Alkyne undergoes a hydration following the Markovnikov rule. You get a propanone. So only the first answer, that is second answer will be the C, that is oxo process. In this reaction, a compound with propene when treated with the carbon monoxide and hydrogen, a catalyst, a cobalt with a tetracarbonyl. So these two actually gives a formaldehyde in situ, and it will be added following the Markovnikov rule. Major product is called here a CHO. However, if the reaction is continued, the H is added, CHO is added here, you will get a primary alcohols also. If you can stop at this level, actually 1 degree aldehyde, that is aldehydes will be formed. So you also get a CHO on the last carbon also. The process is called oxo process. This is called oxo process. So the aldehyde he was asking, so the answer B will be the right answer. So let's go for the question number 2. Arrange the reactivity of the given 4 compounds in decreasing order of nucleophilic addition. Nucleophilic addition is a reaction wherein a C double bond O adds a nucleophile minus, will be adding on the first, followed by an electrophile like plus will be added on the second step. This is a nucleophilic addition reaction. Toward that reaction, the options given is an amide, ester, and aldehyde and ketone. So in the aldehyde and ketone, we have a one side hydrogen containing aldehyde, and a ketone contains 2 sides alkyls. So more the alkyl groups, the carbocation formed here will be stabilized. So therefore less will be the reactivity. Among the aldehyde and ketone, aldehyde will be the more reactive than ketone. In the amides and ester, what happens? Amides will have a NH2 function. This NH2 will have a stabilization through this lone pair. So the carbonyl compound always in the resonance, so therefore nucleophilic addition will be very less. Similar the case with the ester also, but the donation of electron and showing the resonance in this case better. Therefore the first comes aldehyde, and then comes the ketones, then comes the esters, and then comes the amides. Amides is the best because the less the electronegativity of the nitrogen, more will be the plasma effect. So therefore stabilization of the carbonyl group through resonance will be more. So the less reactivity will be there. So the order will be the aldehyde, that is first 3 comes, then ketone 4, 3, 4, followed by the ester, that is 2 and 1. That answer goes to therefore B. Answer B is the right answer. That is once again the aldehyde, ketone, ester and amide is the order of reactivity. So let's go for the question 3. The question is, in the reaction sequence, a benzaldehyde is treated with the sodium cyanide in medium of the acidic medium. So you will get a cyanohydrin. The cyanohydrin is hydrolyzed to give the carboxylic acid. So the reaction is like here, a benzaldehyde undergoes a reaction with the sodium cyanide. Cyanide minus attacks on the carbon. In the hydrolysis reaction, the sodium replaced by the H, so therefore you will get a cyanohydrin. The O will become into OH, a cyanide is added. This undergoes a hydrolysis reaction to get a carboxylic acid. This carboxylic acid while formation, this is a trigonal planar carbon, so cyanide can come from the both the sides, therefore you will get the D as well as the L. So it is an optically active center, so you are going to get the two types of the answer. So he is giving the options here. Optically inactive compound, that's wrong. Optically active alpha hydroxy acid, it's not one acid, two should be the answer. Racemic mixture of two optically active alpha hydroxy acid, that is the right answer. Racemic mixture of two optically active secondary alcohols, this is the actually it is a 2-degree alcohols, but it is not the carboxyl, it is the carboxylic acid plus alpha hydroxy acids are the answers. It has a common name also. If the R is equals to phenyl here, then this is called a mandelic acid or mandalonic acid. It's an optically center is created, DL mixture is formed. So the answer goes to the C. So let's go for the question number 4. Which one of the following pairs can be distinguished by the use of sodium bisulfate? Actually, sodium bisulfate is the reagent prepared in a saturated manner and then added to the carbonyl compounds. They give the white crystalline derivatives. And these aldehydes and ketone both gives. Therefore, using this you cannot differentiate aldehyde and ketones. However, the aldehydes and ketones can be differentiated versus some other compound. So therefore, it here the option C. A is acetaldehyde versus acetone, one aldehyde ketone, no. So B is a acetone versus a acetophenone, both are ketones, no. C is a ketone versus another ketone, that is also not possible. D is an aldehyde versus an alkane. So here it is possible, aldehydes gives a white color precipitate, alkanes do not react. So therefore, one can go for the option D. Answer is D. So aldehyde versus an alkane we can differentiate, because the moment aldehyde, if it is added sodium bisulfite, a white color precipitate is formed. It's an addition, nucleophilic addition reaction takes place, which is not possible with the alkane. Therefore, one can differentiate. So answer is D. So let's go for the question number 5. Which one of the following compounds will give dimethyl glycol with a SeO2, that is selenium dioxide, is an oxidizing agent. Generally a carbonyl group, if it is there already, side by you will get another carbonyl group. If alkene is there, you will get allylic hydroxylation also. But the question, you see options are given acetone. Acetone will give a one carbonyl group side by, means methyl glycol is formed. Acetophenone will give a phenyl glycol. Ethyl methyl ketone. Ethyl methyl ketone means one side you have a methyl and the other side you have a ethyl. So this when selenium dioxide is added, you will get that also will become ketone. So this is glycol containing two methyls. So this is nothing but the dimethyl glycol. So this is the right answer, ethyl methyl ketone. So propanaldehyde will give the again methyl glycol. So only the expected answer is ethyl methyl ketone. So answer is C therefore. So let's go for the question number 6. Metabromoperbenzoic acid can oxidize the one of these 4 compounds. What is the compound he is asking? Alkenes undergoes epoxidation. This metabromoperbenzoic acid is nothing but the benzoic acid containing a 1 oxygen extra. This is called a per bond. So and it is having this type of the per oxygen. A halogen chloro or bromo, example is given bromo, but we can take also a metachloro. So this is a minus I effect will be there. So withdrawing group will be there. It imparts a senescent oxygen readily and becomes into a carboxylic acid. So this can oxidize the alkenes into epoxides, aldehydes into acids, ketones also side by you will get a O and you will get a ester formation. All of these is the right answer. So answer D will be the right answer. D is the right answer. So all can be oxidized with the perbenzoic acid. So let's go for the 7th question. The question is, arrange the acidity of given 4 compounds in decreasing order. Actually there is no direct carboxylic acid here. One is acetylene, that is the first option is given a ketone 1,3-diketone, and the second option is acetone. Third option is acetylene, it is known for the acidity. and the fourth option is a carbonyl compound. So this carbonyl group, whenever it is attached with the hydrogen, this hydrogen will be showing the hyperconjugation and can be given out as a H plus. So the alpha hydrogen present in the carbonyl compounds is known for the acidity. However, if this carbonyl group is attached with in between the two carbonyl groups, this can show the hyperconjugation either side. So this particular hydrogen is called active hydrogen. This is called active hydrogen. This is more acidic than the simple one carbonyl group. So therefore, it is the decreasing order, means first one you have to arrange a number one, that is itself is the diketone containing in between CH2, that is called active methylene group, is the number one more acidic, followed by the 1 and the 4, that is a acetaldehyde, and in acetone we have a one carbonyl group is shared by the 6 hydrogen, so therefore acidity will be less. So therefore 1 followed by the 4, 4 followed by the 2, that is acetone. Then lastly acetylene. Acetylene is no doubt acidic, but it is a weak acid. It is a weak acid than even water also. So therefore the order is a diketone number 1, followed by the acetaldehyde 4, followed by the acetone 2, then lastly the 3. So the option B will be the right answer. So acetylene is acidic, but it is very weak acid when compared with all these alpha hydrogens of the carbonyl compounds. So let's go for the question number 8. Carbonyl compounds having alpha hydrogen give which of the following reactions? The first one he said enolization, second option halogenation, third option deuterium exchange reaction, third or fourth option all of these. Answer is D actually, that is all are correct, because whenever carbonyl group is attached with the alpha hydrogen, as we have seen in the last question, this hydrogen can show the hyperconjugation, so followed by the enolization. Hyperconjugation means hydrogen will be there only, but the double bond is shifted and goes into a O minus. This is the stage is called hyperconjugation. Hyperconjugation can be shown with a resonance symbol, but if the proton is shifted here, then we will get a system like this which is having a enol. So this enol and the carbonyl compound is in equilibrium. This is called the tautomerism. So this hydrogen shows what a enol formation, nothing but the same thing, or this enol hydrogen, this hydrogen is detached and attached, so therefore the compounds undergo halogenation whenever treated with directly, even with the basic medium also. But even direct also the alpha halogenation takes place damn easy here. So this is what halogenation is also right, and this hydrogen can exchange with a D2O. If you add the hydrogens can exchange with a D also. So all this A, B, C are right. So therefore the last option, that is the all of these, is the right answer. So answer D will be the right answer. D will be the right answer. So let's go for the question 9. So match the column with the column 2, that's the matrix type of the question. Column 1 we have a acetophenone and a nitrobenzaldehyde and an alkene having a double bond, alpha beta unsaturated carbonyl compound, and there is a 2 carbonyl groups side by having a OH, that is a phenolic dialdehyde is there. The other side we have options Michael addition, iodoform reaction, aldol condensation, Perkin condensation, and Cannizzaro reaction. So the first A, let us examine this acetophenone he has given. So we have alpha hydrogen, therefore this undergoes the Perkin condensation. This can undergo Perkin condensation. This undergoes a iodoform reaction because CH3 is there. Iodoform reaction it is there. Perkin condensation, that is Q and S will be there for A. And for the compound B we have a aldehyde, that's all. This aldehyde can go the Cannizzaro reaction, it can undergo Perkin condensation, it undergo S and T. And the third one we have a unsaturated carbonyl group. Whenever there is a carbonyl group attached to this unsaturation, it undergoes looks like this ene undergoes a electrophilic addition reaction, but this is not the taking place here. in accordance with this carbonyl group, a nucleophilic addition takes place here. For example, if the HCl is added or HCN is added, this carbonyl group is polarized and the double bond is polarized. Here we have a minus charge, here we will have a plus charge. In general, the plus charge will be on the carbon of the carbonyl. So the nucleophile attacks here and electrophile attacks, nucleophilic addition completes. But in this case, what happens? Cyanide will attack here, H will attack here. So you will get a cyanide addition here and a double bond and a O will become OH. But the hydrogen, it is a ene also tautomerizes to give the H comes back to here. So you will get a C double bond O. Once again carbonyl group is formed. So what is added means cyanide and hydrogen. It is added on the double bond following the nucleophilic addition reaction. This type of nucleophilic addition reaction, however, it's not just HCN, but we should have a react to the hydrogen. A hydrogen which is having this type of hydrogen, if it is added on this carbonyl group, that is, this ene is not an ordinary ene, it is attached with CO, this type of ene, and this type of CH addition on this one is called Michael addition, is a rare reaction, but this type of reactions takes place only the option C takes place. This Michael addition, that is P can be taken by only the C. So if you have that combination C and P, then we can go for that. C also gives the iodoform reaction because there is a CH3 attached to CO. So the last D, that is two carbonyl groups. Two carbonyl groups can undergo the Cannizzaro reaction, can undergo Perkin condensation, right? Aromatic aldehydes undergo Perkin condensation, Cannizzaro, but not aldol. There is no iodoform reaction. So all these combinations goes to the only the option C will be the right answer. So option C is the right answer, that is the QR, and B for the ST, and C for the PQR, and D for the ST. That is the answer. C is the right answer. So let's go for the question number 10. The question is product A of the reaction is. So in this reaction, a compound with benzene and one side a carbonyl group is there, a 5-membered ring is there. This compound is treated with HCN followed by the lithium aluminum hydride. So therefore, what happens when HCN is added? A cyanide is added on the carbon, the H is added on the O. So you will get the carbonyl group will become into the O will become OH, a cyanide is added. This is the first case. Followed by we had a lithium aluminum hydride reduction. So this will become CH2NH2. In the reduction, the compound is changed to CH2NH2. A ring is closed here. Then this compound is subsequently undergoes a sodium nitrite. This is a nitrous acid reaction. So this will become into a hydroxy compound. 1 degree amines undergo diazotization followed by the decomposition that gives a hydroxy compound. There is already one OH is there. This is a sort of a pinacol now. See, this is a glycol, is a pinacol type of reaction, which is because acidic medium is there, which also extends into a rearrangement. The proton attacks on this one and liberation of water carbocation, and the ring expansion takes place. You will get a 6-membered ring with a OH. This OH will be removed and you will get a carbonyl group. So therefore, you will get a one more ring which is having a 6-membered ring, and we have a hydroxy group which is oxidized to the carbonyl group. So this is the right answer. So option A is a naphthalene, B is a double bond ketone on the second carbon, but the option C is a ketone at the second carbon. This is the right answer. The other one is reduced from. So answer C is the right answer. So we have the rearrangement reaction here. It is called pinacol-pinacolone. Pinacol-pinacolone rearrangement. Pinacol-pinacolone rearrangement. This is a rearrangement reaction. This is a nucleophilic addition. However, cyanide reduction will give 1 degree amine. Nitrous acid will generate this reaction, followed by the acid. Same acid is used for the pinacol rearrangement also. Let's go for the question number 11. The benzaldehyde is treated with ethyl acetoacetate. Ethyl acetoacetate has a CH2 group, which is a reactive group. So that is going to condense in presence of a strong base. X is formed. The X is treated with the hydrolysis followed by the heating. So the Y and the Z. So therefore X, Y, Z, all the three compounds are asked here, and so the A is equals to 3 options are given, and that is the actually right answer. So what happens in this reaction? Let us see. A benzaldehyde is undergoing a reaction with the CH2 group containing in ethyl acetoacetate. That is this is aceto group containing this is acetic acid with ethyl acetoacetate. So the condensation taking place in a strong base. The base is given here is a R2NH, that is a 2-degree amine. Diethylamine is given, or dimethylamine. This will take this condensation reaction. So a product is formed like this: a phenyl with C double bond O, and one side is COOET, the other side is CO methyl. So this undergoes a hydrolysis reaction. In this hydrolysis, the ester is undergone a hydrolysis. So phenyl CH double bond phenyl CH with COOH, carboxylic acid, which is a, by nature, if you see, this is a alpha, that is a beta type of compound. So therefore what happens, it undergoes a decarboxylation easily. So on heating it gives a phenyl with unsaturated with a COCH3. This is the final answer. So therefore first option in the A, you see there is a condensed product and then hydrolyzed product with 2 COOH group, and then the COOH is last. So you will get a phenyl with a cinnamic type of the ketone is derived. That is the answer. A is the right answer. So you work out first what happens in the reaction and correlate with the XYZ which is given in the 3 options. That must be the right answer. So let's go to the question number 12. The given reaction, the reaction is given as a nitrobenzaldehyde, and some reagent it was converting into a nitro group is protected, but the CHO is affected to give the CH2OH. That also part reduction. Its total reduction would have given a CH3. A Clemmensen reduction type of reaction will give the CH3. So here it is X will be the reagent he is asking. It is zinc and HCl. A Clemmensen reduction will give the CH3. Tin and HCl, nascent hydrogen, will give a CH2OH will be formed, but NO2 also will be reduced. Lithium aluminum hydride also converts CHO into CH2OH, but NO2 also will be reduced. So we want to protect the NO2 and affect the CHO, means the last option it is formaldehyde. So when benzaldehyde and formaldehyde, nitrobenzaldehyde and formaldehyde, if it is treated, they undergo a the Cannizzaro reaction, different types of the molecule crossed Cannizzaro, and that too different types Cannizzaro reaction. In the Cannizzaro reaction, in presence of the basic medium, the formaldehyde and the base added. So one undergoes reduction, one undergoes oxidation. The concept is, out of the 2 aldehydes, the aromatic aldehyde is less reactive, so therefore OH attacks on this one and expel the H minus attacks on that. So this compound undergoes reduction. Aromatic compound undergoes reduction to give the alcohol. However, the formaldehyde will become into the formic acid. So we are able to protect the NO2 group without reducing. So the correct option is answer D. That is, a Cannizzaro reaction is involved in this option. So formaldehyde base is the right answer. So let's go for the next question, 13. The question is, a mixture of acetaldehyde and formaldehyde are converted into a specific compound given plus formic acid by which of the following reaction? An aldol condensation, a Cannizzaro reaction. Option C is both A and B, and D is the benzoin condensation. Here what is happening is, when formaldehyde is treated, it has 3 alpha hydrogens. So it reacts with the formaldehyde. In the formaldehyde we have a hydrogen this one. So it splits up into alpha proton and anion. The anion will attack here, a proton will add on here. Like that, all these hydrogens will undergo with the 3 moles of formaldehyde, and consequently what comes is, in this reaction, 3 sides you will get a CH2OHs. 3 sides CH2OH. But still we have an aldehyde group. This aldehyde cannot undergo aldol condensation now because already all hydrogens are exhausted. So with the help of the 4th mole of the formaldehyde, 4 moles are consumed here. With the help of 4th mole, this undergoes oxidation, this undergoes reduction. So the bigger the compound will be the less reactive. So therefore this OH attacks on first this. So therefore this undergoes in oxidation to give the formic acid, and this gives the alcohol. So already we have a 3 CH2OHs obtained from the other 3 formaldehydes. So you got this specific type of compound. However, you will get the other products as a minor products, but the major product is here. 3 formaldehydes undergoes aldol addition followed by the Cannizzaro reaction. So therefore in this option, both A, aldol condensation, followed by there is a Cannizzaro reaction also involved. So therefore answer A and B, option C is the right answer. Answer will be the C, which has got a aldol condensation, B Cannizzaro reaction. Let's go for the question. Next question, 14th question. Which halide will participate in Wettig reaction? So you must know the Wettig reaction, but the options are given: one tertiary compound, tertiary butyl chloride, one is aromatic aryl halide, the C is a vinyl halide, the D is a 2-degree the alkyl halides. So what is Wettig reaction means? A carbonyl group having a R1 R2, when treated with a reagent called a phosphorus with a triphenyl, a carbon with the R3 and R4. Where from this compound comes? This is a called a Wettig reagent. Wettig reagent contains a triphenyl phosphorus with a double bond carbon with the 2 more alkyl groups. Here R1 R2 already I have taken. So to differentiate I have taken R3 R4. This comes from the triphenyl phosphorus adding an alkyl halide. Okay, this alkyl halide should be 1 degree or 2 degree. An example, if I take a 2 degree alkyl halide, minimum 2 R's will be there, R3 R4, 1 hydrogen will be there. So this hydrogen is used for the elimination. After adding on this compound, you will get a reagent, a phenyl with the triphenyl. This carbon is added, okay. So containing R3 R4, 1 H will be there. So you have a plus here. So this after adding the halogen will be here, X minus. This X minus and H plus will be removed in presence of a strong base. A base is suggested there. So elimination of this X and H will give a double bond formation. This type of carbon containing R3 R4 means 2 R's should be there, so that the hydrogen eliminate. If all alkyls are there, this hydrogen cannot be eliminated. So therefore, what type of alkyl halides are useful? Only 1 degree and 2 degree. This halide, when I use, what happens next? Finally, what happens? The oxygen, they undergo an addition slowly. A betaine type of the formation ring is formed, and the P takes the oxygen, carbon will come here. Final answer will be a double bond with the carbon containing a R3 R4 and the R1 R2 already there. This phosphorus will take this oxygen, you will get a phosphorone. So triphenyl phosphone is formed, and that is a head exchange. This group will be imparted here, oxygen will go there. That's called Wettig reaction. The question is here, what type of alkyl halide will participate in the formation of that is Wettig reagent? Means only 1 degree, 2 degree is eligible. So therefore we have a 2 degree alkyl halide. Option D is the right answer. The reaction is a very popular reaction known as Wettig reaction. So let's go for the next question, 15th question. In the reaction sequence, a cyclohexanone is given, then treated with a a 2-degree amine with a cyclic nature, followed by an alkyl halide in acidic medium. An alkyl chloride is given, that is ethyl chloride, and he is expecting a product X here after 2 steps. What is this X he is asking? Let us examine the reaction. This 2-degree amine undergo a reaction with this one. This undergoes a enolization and exists as a enol formation of this compound like this. This reacts with this one and eliminates a water, or it is a nucleophilic substitution. N with lone pair, substitute the OH. So finally what happens, you get an intermediate product like this. En with amine is formed. This is called enamine. Enamine undergoes a electrophilic addition reaction. In accordance with this, lone pair will be supporting and you will getting a minus charge here. So therefore if Rx is added, X is a minus, R is a plus, the R plus will attack here and the X goes here, and finally what happens, R is added, that is your alkyl group here, and this the X is added here, you will get a okay, this if it goes back, this double bond goes back, you will get a N plus here. And this X and eliminates N, so you will get a double bond here. This double bond on hydrolysis, so 2 OHs and 2 Hs, that will become 2-degree amine, but 2 OHs eliminates and you will get a ketone back. See here a ketone is again formed, but this alkylation. So what is this reaction? It is one of the alpha hydrogen we are treating or replacing with alkyl group through this enamine process. Okay, it's an electrophilic addition taking place, but it is a replacement. Net reaction is a replacement of the alkyl group. So you go for that answer. Answer in the A is a alkylidine derivative, no. It is a hydroxy and alkyl, no. It is the alkylation and the alpha, that is option C is the right answer. Answer C, you find a alkyl group, that is alkyl chlorbromide we have taken, and product alpha alkylation is taking place. So answer C is the right answer. So let's go for the 16th question. Formaldehyde reacts with ammonia. Actually formaldehyde is a very small compound, but ammonia, a simple reaction you can write this condensation reaction, aldimine is formed. But this leads to the polymerization reaction. It will not stay back, it will go on add, and finally what you will get is 6 that is 6 formaldehydes, 4 ammonias are participated in this reaction to give this CH2 6 times, N 4 times. This is called hexamethylene. Hexamethylene, that is CH2s are 6, hexamethylene. So nitrogens are 4, therefore it is called tetramine, hexamethylene tetramine. Hexamethylene tetramine. It has a beautiful structure. We have a CH2 with a and we have one more nitrogen here attached to. Everywhere there is a CH2 through the nitrogen, isn't it? One CH2 here, also one CH2, NCH2 is there. So this is a 4 ammonias are there attached through the hexamethylene tetramine. So N attached to the CH2, isn't it? Hexamethylene, CH only will be there. CH2, N will be there. Hexamethylene tetramine. You have actually a 3-dimensional structure may be written like this. Hexamine, it is also called commercially hexamine. Every nitrogen will have a 3 CH2 linkages. This is called a hexamine also. Hexamethylene tetramine is also called hexamine. Commercially it is used as a diuretic medicine under the name urotropin. Has got lot of applications. It's a smaller polymerized product known as hexamethylene tetramine. So answer goes to the D. So let's go for the 17th question. Acetaldehyde reacts with ammonia to give the one of this product. In this product, acetaldehyde and ammonia, and giving a product. Acetaldehyde will have a CH3 C double bond O, which condenses with the ammonia. So the two hydrogens and O will be eliminated, and you will get a aldimine. This aldimine undergoes a reaction with the subsequently what happens, a 6-membered ring is formed containing the acetaldehyde plus nitrogen, acetaldehyde with nitrogen, acetaldehyde with nitrogen. So this is one aldimine, and this undergoes addition on this one. A cyclic type of the product is formed containing the 3 methyls outside and the 3 nitrogens inside will be there. And this is the product. Answer C is the right answer. Let's go for the question 18. The question is, match the list 1 with the list 2 and select the correct answer using the codes given below. The list 1 is containing an ene with the aldehyde, which is reacting with the sodium borohydride. Sodium borohydride. This reduces the aldehyde selectively, protecting the ene. So you will get a CH2OH. Okay. So we will search that answer in the that is unsaturated alcohol. That is for A, 3 is the right answer. For B, what is the reaction? The B is a benzaldehyde is taken. Benzaldehyde is undergoing a reaction with the methylamine. This is a 1 degree amine. So therefore it condenses and you will get elimination of water. The products are known as Schiff bases. They are called Schiff bases. So the B option is Schiff base means 2. That is second for the B only there. And the third option is a carbonyl compound reacting with 2 degree amine. A carbonyl compound reacting with the 2 degree amine. However, we have a alpha hydrogen, therefore it undergoes enol formation, then eliminates. You will get a enamine. This type of the compound is formed. This is called enamine. 2 degree amines with the carbonyl compound, tautomerizes, enol comes, and because there is no 2 hydrogen, only 1 hydrogen cannot eliminate. So it will become a hydroxy group. Enolizes and develops a hydroxy, and this hydroxy and H will be going out as a water. Nucleophilic substitution takes place. Finally, formaldehyde reacting with the alcohols. A carbonyl compound reacting with the alcohol. First mole of alcohol react in the nucleophilic addition. So OH is formed. You will get a OR and the OH. This is called hemiacetal formation. The next second mole of the alcohol will substitute. RO minus will replace this OH. So you will get a 2 ROs, OR and the OR. This is called acetal formation. So now they match the following. This is unsaturated. First one is unsaturated, the alcohol. Second one is Schiff base. Third one is enamine. Fourth one is acetal formation. So that combination goes for the answer A, A3, B2 and C4 and the D1. That is the right answer. Answer goes to the A. Isn't it? Answer goes to the A. A is the right answer. So let's go for the question number 19. Next question. This is a straightforward question. In the given reaction, there is a benzaldehyde containing some other groups also. But other groups are safe here. One is ether, the other one is alcohol. So you want to reduce with a reagent known as zinc with Hg, that is amalgamated zinc and the concentrated HCl. This is known for the Clemmensen reduction. Clemmensen reduction. So this reduction exclusively converts the aldehyde group into the alkyl group, that is CHO. Total reduction takes place, CH3. The other groups like the ethers and alcohols will be as it is, will be protected. That is the speciality of this Clemmensen reaction. So search for this answer. Answer A is the right answer. The aldehyde is converted to methyl group, and the methoxy, that is the anisole type of group, and the phenolic groups are protected. So answer A is the right answer. Let's go for the next question. 20th question. Cannizzaro reaction is an example. In the Cannizzaro reaction, what happens? If two aldehydes are there which have no alpha hydrogen, two compounds, one will become into the acid, one will become into the alcohol. So what is this reaction? It is a redox reaction. One undergoes oxidation, one undergoes reduction simultaneously. So with the help of the base, this is called what? A Cannizzaro reaction. So this Cannizzaro reaction, redox, that is reduction and oxidation simultaneously taking place. So the answer A is the right answer. A is the right answer. So let's go for the 21 question. That is, which one of the combinations will give the propanaldehyde on dry distillation? So the answer must be the propanaldehyde. Answer must be the propanaldehyde. Let us say in the first option, a calcium salt of the benzoate and the calcium salt of the formate. Whenever calcium formate is added, aldehydes are formed. As such, if you distill calcium acetate, for example, if you distill, you will get acetone. Calcium benzoate, if you distill, benzophenone will be the formed. So a calcium formate is the right combination, but the benzophenone, that is, you will get a benzophenone in the case, because calcium, the salt of the benzoate you have selected, you will get a ketone, no doubt, but you will get the aldehyde comes, benzaldehyde will be the first answer. In the second answer, you have a calcium acetate and the propanoate, a combination of two calcium salts, both gives the ketones. Third option C, calcium propanoate and calcium formate. This is the right option. Calcium propanoate plus calcium formate. Whenever calcium salt of the formic acid is taken, reduction is taking place, and this gives the aldehyde. If it is not there, you could have get a 3-pentanone, double reaction taking place. One calcium carbonate will go, but it will be doubled so that a one carbon less ketone is formed. So therefore, in this reaction, it is the right combination that gives this one. So the option C is the right answer. Next question, 22. The cyclohexane is nothing but a 6 carbon with a ring. This on reaction with UV light and H mu, that is photolytically chlorination, maybe monochloro or dichloro is formed. Alcoholic KOH will give a alkene formation. So let us hope for the monochlorination. A chlorine is there, then alcoholic KOH will give the elimination. So we will get alkene, hope. And that this alkene on reaction with the ozonolysis in the reductive medium. So it will give a double bond will be cut, and you will get a CHO and again a CHO. This is nothing but a 6 carbon containing the two aldehydes. Search for the answer now. The product C will be the hexanol. It's a diol. No. So B answer hexanone. That's wrong. So C is a 3-hexanone. That is also wrong. Hexane diol, that is the two aldehydes containing a hexane. This is the option D. Answer D is the right answer therefore. So next question, 23. In this reaction, a compound is given, a carbonyl group is there and alkyne is there. This alkyne is treated with a reagent here, that is a SiA taken twice with BH. So it is almost equals to the boron with the 3 hydrogens. We know that BH3 is known as borane, which exists in the diborane form. So when the diborane is added also, it follows the Markovnikov principal type, but the product comes as a anti-Markovnikov product when subsequently treated with the hydrogen peroxide. This SiA is nothing but the boron containing the 2 alkyl groups. These alkyls are nothing but the isoamyl type. This is actually isoamyl linked at the second carbon. So therefore it is twice. So he is saying it is a dis isoamyl boron with the hydrogen. So this boron is electron deficient, boron contains plus and H is minus, which adds on this alkyne following the Markovnikov rule. So therefore B goes to the terminal carbon. So which on this one reaction will become a like this, a boron with the hydrogen, and which on treatment subsequently with the hydrogen peroxide, OH and OH, this one OH will be replacing, one OH goes to the boron and another OH goes to here. So enol is formed. This enol, phenyl is there, however, this enol tautomerizes, you will get an aldehyde group. So finally what comes is a benzene, and this aldehyde will be there already, a carbonyl group will be there, side by you will get a CH2CHO. So this is the final answer. Search for this answer in this reaction. It is nothing but a hydroboration of the alkynes. Following the Markovnikov rule only we have followed, but finally the product comes as a anti-Markovnikov rule hydration type of reaction. So the answer goes to the answer B is the right answer. In this reaction the carbonyl group is silent, and only the alkyne is undergoing addition. That's this treatment should be the hydrogen peroxide. If it is water is added, H comes here, it will become alkene. Alkynes will become alkene. But you must be adding a hydrogen peroxide so that each side you will get OH. So this enol tautomerizes to give the aldehyde. Okay. So next goes 24th question. In the given reaction, a alkene, exocyclic alkene is there, and other side is a ketone is there, it's a cyclohexanone, and with sodium borohydride it is understood that the ketone undergoes reduction, not the alkene, right? Then that reduced alcohol treatment with the BH3 followed by the hydrogen peroxide, sodium borohydride will give a reduced form alcohol actually, and then treatment with the BH3. So the option A is A and B both is asked. First reduced form is asked, then followed by the alcohol is also asked. So the reaction is here, what is happening? Two functional groups are there, one is alkene is there, the other side is carbonyl group is there. In the first step what he is doing, he is adding a reducing agent, sodium borohydride. Sodium borohydride reduces here and this is protected. So the double bond will be as it is protected, but the other side you will get a alcohol. Now this subsequently he gone for the hydroboration BH3, just last time reaction we have seen, they separately treated with the hydrogen peroxide H2O2. So this BH3 B add here and H add here following the Markovnikov rule only, that is the H goes to the H, isn't it? B plus, this is a plus, electron deficient. So will be added here, not like electrophile nucleophile exactly, but the BH slowly adds on this one, so that the electron deficient adds here and the excess H adds here. Later it undergoes a that is hydroxy, that is hydrogen peroxide, and it will become an alcohol here. So the final answer will be the cyclohexane containing a one side alcohol, the other side carbon with alcohol, that is CH2OH. Search for this answer. So there are two answers. This is the first answer A and this is the second answer B. So A, B are the option A is the right answer. So the first is ene with the alkyl alcohol. Answer will be the A. So let's go for the next question, 25th question. Arrange the given compounds for reactivity in decreasing order for nucleophilic addition. So the carbonyl compounds undergo one favorable reaction, that is the characteristic reaction, nucleophilic addition, and if a nucleophile electrophile combination containing reagents, if it is added, first nucleophile attacks because of the C plus more the reactivity over the O minus. First nucleophile adds followed by the electrophile adds as a second step. This is second step. So first step is nucleophile adds. Toward that reaction it is said that if alkyl group is there, inductive effect decreases. If a aromatic group is there, that is if any benzene such groups are there, plus M effect stabilizes. Steric hindrance also decreases. So the smaller the aldehyde, it is given like all aldehydes are more reactive than ketones, right? Within the aldehydes, we have a aromatic and aliphatic. Aliphatic are more reactive than the aromatic. Within the aliphatic, we have a smaller one and the bigger one. Both are aliphatic, you go for this criteria. So based on that, we can differentiate that the formaldehyde is the smallest one and aliphatic. So it is a first goes, and we have a compound with benzene also. Benzene with ketone is there, benzene with aldehyde is there. So the fourth option goes to the last. So finally the 1, 2, 3, 4 is the right answer. That is answer C is the right answer. In this the aldehyde without any group, formaldehyde, and then an aldehyde with benzaldehyde, then acetone, and then the acetophenone is arranged. 1, 2, 3, 4 is arranged. So therefore the option C is the right answer.